Let's start it.
Assalamualaikum dan selamat sejahtera saya ucapkan kepada pensyarah saya Madam Norsiah dan kawan-kawan sekalian. Hari ini saya AZRUL&FARIS akan bentangkan final project saya berkaitan mechanical component. I want to introduction first. Number one, overview. A base plate with hole for mounting a vertical support rib connecting the base to the cylindrical housing, ensuring strength and rigidity. Number two, purpose. Provide stable support for a rotating shaft or bearing. Maintain precise alignment between mechanical parts, preventing vibration or misalignment. Transfer load from the rotating alignment to the supporting structure, such as a machine frame or chassis. Ensure ease of assembly by allowing the component to be bolted securely in place. Number three, relevance. Mechanical systems such as conveyor system, motor or gear assemblies, manufacturing equipment where shaft or roller require accurate alignment and support. Engineering project as a standard example for teaching orthographic and isometric drawing, dimensioning and tolerancing practice. Design process. The design process began with concept development, where the main objective was to create a support bracket with a cylindrical housing capable of securely holding a rotating shaft or bearing. The process followed several key stages. Initial sketching and idea generation. Early sketches were made to explore different configuration of the base support rib and cylindrical section. Dimensional planning and standardization. Standard mechanical dimensions were applied based on typical component size and mounting requirement. Isometric and orthographic drawing generation. Once the 3D model was complete, both isometric and orthographic projection were produced with appropriate dimensioning and annotation to communicate the design clearly for manufacturing or presentation. Now we go to the next slide, the challenge phase. Ensuring dimensional accuracy. Some dimension initially cause misalignment between the base and cylindrical part. Understanding proper projection technique. Translating the 3D model into accurate 2D orthographic and isometric view required careful attention to hidden lines and dimension placement. Overcoming challenge. Ensuring dimensional accuracy. Constraint and reference plans were used in the CAD model to automatically maintain alignment and proportional scaling during adjustment. As understanding proper projection technique. CAD drawing standards were followed, including the use of proper projection plans and standardized dimensioning practice taught during the coursework. How to drawing and model meet engineering standard. The drawing and 3D model meet engineering drawing standard through the use of accurate orthographic and isometric projection. The orthographic view clearly show all key dimensions or features, while the isometric view provide a clear 3D visualization of the component. Dimension apply use proper appropriate line type and thickness are used to differentiate visible hidden and dimension lines. The design also maintain correct proportion, symmetry and functional features such as mounting holes and support ribs. Overall, the drawing effective communicate the component form, fit and function in accordance with professional engineering standard. Okay, now we go to the last slide, So, conclusion, overall the drawing and 3D model made engineering drawing standard by using proper projection method, orthographic and isometric, following correct dimensioning, line convention and annotation, ensuring clarity, accuracy and functional representation of the part. This ensure and the component can be manufactured, inspected and assembled accurately based on the provided technical drawing, fulfilling key engineering documentation requirement. Thank you.
Assalamualaikum and greeting to my lecturer, Madam Norasiah and all my friends. Today, I, Muhammad Faris Irfan bin Mohidi, will present my final project related to mechanical component. Okay, the mechanical component that I choose is pendakap, iaitu bracket atau lebih dikenali sebagai penyambung yang acap kali diguna di dalam engine ataupun mesin industri. Okay, ini merupakan perkara yang akan saya terangkan dalam presentation saya hari ini, iaitu introduction. Yang kedua, design and process. Yang ketiga dan akhir sekali ialah drawing and model. Okay, this is my project. Ini merupakan view dari isometric, iaitu melibatkan 3D yang saya hasilkan melalui sebuah software yang bernama AutoCAD. Ini merupakan isometric. Dan ini merupakan unjuran ortografi, iaitu melibatkan pandangan pelan, iaitu pandangan atas, pandangan depan dan pandangan sisi. Okey, subtopik pertama iaitu introduction yang akan saya tekankan ialah overview, purpose and functionality and the relevance. Okay, for the overview, this component is a fundamental supporting or connecting part in mechanical assembly or structure. For the purpose and functions, secara primary goal is to connect two or more parts or to provide rigid support for stabilizations with a large system. Okay, for the specific function is this mechanical part. Our mechanical component is more to likely serves to connect a shaft or rod by using the cylindrical end with diameter 30 to a base or another structures facilitated by the connecting bolt holes. Okay, its relevance. For the relevance point is bracket are essential elements in mechanical engineering. A robust and accurately dimensioned design is crucial for ensuring stability and load bearing capability in the final system. Okay, for the design and process, I will highlight the two things, which is how to describe. I gonna describe the design process. Another one is challenges faced and the solutions. Okay, firstly, describe the design process. For the first point is defining function. The primary goal is established to create a rigid component capable of connecting and supporting a rotting shaft by using the large hole, which is the diameter is 30, to a fixed surface or frame using the smaller hole. The fixed surface or frame is something that cannot be changed. It's already fixed, yang tidak boleh berubah. Okay. Another point is conceptual sketching. Initial shapes are chosen. The design combines a cylindrical hub or rotation connection with a flat arm for structural connections. Okay. The last point is 2D drawing generation. The final 3D model is converted into formal 2D drawings using orthographic projections, which is the orthographic projection is pandangan dari front, top and side views and fully dimensions to provide manufacturing instructions. Okay, next, challenges faced and how to address it. Okay, before we start, I'm gonna talk to you guys about these challenges. Designing mechanical components always involves balancing functionality, strength and manufacturability. Okay, there is two challenges that I face and I gonna share with you guys, which is the first challenge is dimensional accuracy. For the descriptions, ensuring all critical dimensions, especially the radius 10 diameter 30, 20, and spacing 50 are precise for smooth assembly and functions. So the solution and how I address it is by utilizing geometric constraints within the CAD software and cross-checking of the 2D orthographic view for consistency. Okay, for the next and the last challenge is the second challenge is structural integrity. For the description, ensuring the connecting arm section is strong enough to withstand the operational loads without failure. So the solution, how I address it is by incorporate the web structure, the thin connecting materials to increase stiffness and reinforcing potential stress points. For example, adding fillets or rounds that eliminate a lot. Okay, fillets and rounds taught not explicitly dimension to minimize stress concentrations. Okay, the last thing that I could not deliver to you guys is about the drawing and models. Drawing and models. I'm gonna to discuss about two things, which is a 3D model and 2D drawing. At the first, the 3D models provide a clear visual for understanding the final shape and overall structures. The 2D drawing is used third-angle projection, which is a widely accepted international standard to show all view, which is front, top, and the side view. Okay. But the last point is standard compliance. Okay, first, dimension. All measurements are in millimeter, or clearly placed, telling the manufacturer exactly what size make part. Okay, the second point is features. Standard center line and hidden lines are included to communicate the positions and size of internal hole. Okay, for the last point is documentations. The drawing contains a complete title block and the correct projection symbol for formal Chinese record. Okay, for the title block, you guys can see that I use more to myself. I put my name over there, my class, actually about the titles. Okay, for the dimension, you guys can see I use what type of dimension for this one, which is the different color is meaning a different thing. Okay, you guys can see.
That's all from us.
Okay guys, this is the end of our presentations. That's all for the presentation for me and my partner Azrul Iqbal bin Irwandi about the mechanical component. If you have any questions, you can scan this QR code. Thank you.